and my name is Samarth Narula. I'm going to be your instructor for today. I have total 6 years of experience in IT industry. Currently, I'm working as a technical lead tech architect for one of the biggest telecom giant. And welcome to this training. So let's start with the curriculum. So this is the curriculum. This is what you're going to learn in the next 4 hours. So this training is about Hibernate and MicroStream. So in today's training, you're going to see how we can use Spring Boot Hibernate, how we can create one-to-one mapping between two entities, how we can establish many-to-one mapping and one-to-many mapping between different entities, and how we can establish many-to-many relationship between two different entities. Then you're going to learn about MicroStream, which is the next level serializable framework. So it overcomes the serializable framework limitations that Java library has. So it's a framework which allows you to store your Java graphs directly into any targeted data store and retrieve it from that targeted data store back to your JVM heap memory. So you're going to see a live demo of it. So don't worry. When you'll see the live demo, you'll come to understand the features of this library. Okay, let's start with the topic. The first one is one-to-one mapping. Okay.
Samarth, this will be 4 hour training, so we will be having break in between.
Yes, we'll be having short breaks in between.
Okay.
Yeah. So it's good that you're only three of you, so you can ask your doubts, get the most out of this training. If there is a very large audience, then you don't get to ask too many doubts. Okay, so let's start with this one, Spring Boot Hibernate one-to-one mapping. So the entire training will be 90% practicals and 10% theory. So let's start with the first hands-on walkthrough of the provided Spring Boot project. So as part of this hands-on, I'm going to provide you code walkthrough and functionality walkthrough. This is the code. I'll be giving you the GitHub links for this code. So this is the one-to-one mapping project. And here you can see this is the 1 minute. I'm just admitting few students in. Okay. All right. Hi, Sagar.
Hello.
Okay, guys. So Sagar, we have already started and given them walkthrough of the curriculum for today. So this is the curriculum. You can take a screenshot of it if you want to see, like keep the curriculum handy. And we are starting with one-to-one mapping annotation project.
Okay.
Okay, first hands-on. So let me give you walkthrough of this project. This is the project. First is the code walkthrough. So I'll start with the POM file. So we are using the latest version of Spring Boot, which is 3.0.2. We have added these dependencies. We've added the JPA dependency, DevTools dependency, H2 dependency, Lombok dependency, and web dependency, and Open API dependency. Then I've just commented this out. So in between, I was getting the validation exceptions with the latest version of Spring Boot. So I had added this, but then I was not getting when I upgraded the project to a even newer version, maybe from 3.0.1 to 3.0.2. And this is the new one which I've added, Spring Boot starter validation. Okay, so if you guys have attended my fundamental trainings, then you must be aware that this is for creating CRUD APIs. So it offers JPA is used for storing objects for performing CRUD operations onto your database entities. DevTools is to enable rapid application development. H2 is the embedded database. So we are using embedded database so that we don't have to waste time in cleaning up the data. If you use a proper database like SQL database, Postgres database, MySQL database, then a lot of time is spent in the cleanups during the course. So I've used H2, which is an embedded database, and it's a temporary database. That means all the data persisted into the H2 database is lost on application start. Then we are using Lombok. Lombok helps us to avoid a lot of boilerplate code or the unnecessary code. Then we have the web dependency. So web dependency enables us to create APIs, and it provides us with the embedded Tomcat server. And then we have the Open API dependency. By adding this dependency, we have enabled Swagger UI in this project. And to get rid of the exception, so this is a boilerplate dependency that you need to add with Spring Boot version 3.0.0 and further, which is Spring Boot starter validation. Then we have the main file. This is the normal main file. And we are going to comment and uncomment these things as we walk through different contents of this course or different topics of this course. This is the passport entity. Now make yourself familiar with the entity classes. So we have the passport entity and we have created getter setters and everything for this by using Lombok annotation @data. So using @data, we have created getter methods, setter methods, equals, hash code, toString method. Our passport is an entity class. So it is annotated with @entity. This marks passport as an entity class. If you don't have this @entity, then it's a normal Java Pojo class or a model class. If you add @entity to any class, it becomes an entity class. What does entity means? That means that this passport class will get mapped to a passport table in the database when we start this application. So passport has two things. Passport has ID and passport has number. And we are going to comment and uncomment this as we walk through different topics of this course. Then we have student entity. Okay. Guys, is the font size good enough now?
Yes, sir.
Yes.
Okay, thanks.
Yes.
Okay. Then we have student class. Student class is again an entity class. So it's annotated with @entity. And we have created getter setters and everything for these two variables using a Lombok annotation @data. @data is a Lombok annotation which is equivalent of all these Lombok annotations. So it creates getter methods for us, setter methods for us, required args constructor for us, toString for us, equals and hash code method for us. We can view the project outline by pressing Ctrl O on our keyboard, or we can see the project outline by going to window, show view, show view and outline. Okay, so just remember the entity classes, how they look. So for an entity class, there are two things. You need to first of all mark the class as entity class by using @entity JPA annotation. Also, the imports have changed with the latest version. It is now Jakarta persistence entity. Till versions till the older versions before 3.0.0, it was a different package. Now it's Jakarta persistence package. And for the entity class, there are two main important annotations: @entity and @ID. So by using this, we mark a class as an entity class, and by using this @ID, we define a primary key. Then we have application.properties. Here we have configured our H2 database. We have set the username and password for our H2 database. Since we have not set any password, so we can directly log into the H2 database without having to type the password. Then to solve the problem of data SQL not executed on application startup, I've added this property. So there is a data.sql here. So whenever I start this application, all the queries that I've written here will get executed. So from the later versions, from 2.6.0 onwards in Spring Boot, this data.sql was not getting automatically executed. In order to make it automatically executed, we have to add this property here in the property file, spring.jpa.defer data source initialization to true. This will ensure that on application start, our data.sql file will get executed. And these are some other properties which we have added here. Let me give you some explanation. Okay, wait here. So if you want to know about different values that can be assigned to this property, so here's a big explanation for that. I'll just delete it from here. I'll send it in the chat, which explains each and every property and what it does. So right now we have set it to update. What update does is this value instructs Hibernate to update the database schema based on the entity mapping. It will add missing tables, columns, and constraints, but it will not remove or modify existing schema objects. However, it is important to note that this mode is considered risky in production as it may cause data loss or data corruption. But for now, we are using this as this is a training project. So this will ensure that if we are creating any entity class, it will not get deleted and it will just get updated. Yes, students, you will be receiving the recording of this session over the mail. Okay, so you can save this, what I've shared. I've shared all the values and the meaning of those values with you guys. So just ensure that you save it with you so that if you want to refer to it, you can always refer to it. I've shared over chat, so you can copy and save in your notes. Okay, is it clear so far? What is the meaning of all these properties? Okay, till here at least.
Samarth, I cannot see that in the chat that you have shared properties.
Oh, let
Yeah.
me see again. Whom did I share with?
And from where did we take this project? GitHub?
Yeah, let me see. I think I've uploaded my projects to GitHub. I mean, the older versions are there from last year's training, but I've migrated the versions. So let me check the latest one. Let me share it again in the chat. I think I just shared with one student by mistake. Now, can you guys see in the chat the meaning
Yes,
of
Samarth.
different
Yes.
properties? Okay,
Yes.
cool.
Yes.
Let me check my GitHub. I've also shared about me. So if you like this content of this training, then you can refer to my YouTube videos, study further. You can check out my Udemy and Coursera courses and Medium blogs and learn more. Okay, so here Hibernate. I'll just upload it, don't worry. By the end of the session, I'll just push the code, okay? I think in this one it is there, I think. Okay, no, this is empty. So I'll push the code post the training. In that case, what I can do is let me add notes here. So that you can refer it always. So I'm saving the notes here. You can refer the notes from this notes file. By the end of today's session, I'll just remind me that I'll push this code and share the GitHub link with you. Okay, coming to the next property. Spring JPA show SQL. I'll come to this one when I'll start running the application. So this is basically whichever tables get created in the background. This passport will be coming as a table in H2 database. Student will also get mapped as a table in the database, H2 database. So all these things, if whatever queries are getting created and executed in the background, if you want to see that, then this property allows you to see that spring.jpa show SQL true. Now it is a very big queries that gets created and it's not really readable because it comes in one line. If you want to see it in a readable format, then this is the property which formats the query so that you can read it in the console. So the this property spring.jpa properties hibernate formats SQL true. This will basically format your query which is getting printed in the console because of this property. And since we are using H2 database, I've added the H2 dialect here. All right. So that's about all the properties and all the content of this project. This was the main directory. This is the resource directory and all the files. This is the base package. This is the entity package, the main class, the entity classes, the property file, the data.sql. Now let me provide you code walkthrough of this application. So let's start this application.
Samarth, what is the use of line number 13, that H2 dialect?
It's for Java to talk with the H2 database. So all the databases have their own dialects. Dialect is like a language dialect, like how we humans have dialects. Same way, H2 database, different databases have their own dialects. And for JPA to communicate with the different kinds of database, we have to provide the dialect. If you're using a MySQL database, we need to provide the MySQL dialect so that JPA knows it's talking with MySQL database. If we are talking with the, if JPA wants to talk with Postgres database, then you need to provide a Postgres dialect.
Okay.
So that it can understand the, it can convert its object graphs to database specific binaries and then store it in that database.
Got it.
Okay, so our application has started. It's running on port 8080. Let's open this. Let's go to our application. We're going to use H2 console. So we have configured H2 database, so we can log into H2 console. You can copy all these properties from here. So these are the default properties. We can click on connect. So we have successfully logged into our H2 database. First, let me give you a walkthrough of how to use this database, how to execute queries on this. So I just click on this. This copies all the sample queries here. So if you want to execute this query, you'll select this query and you'll click on run selected. Now it has created a table test with columns, ID and name. Now if you want to insert some data, again, you can select and click on run. Now if you want to fire a select query on this table and order by ID, you can select this query and click on run selected. Same way, you can select things and run things. If you want to run everything on this query editor, you can click run. By default, auto commit is on. By default, max rows you'll see is 1000 and auto complete is off. If you want to clear everything from here, you can click on clear and it will delete all the queries. Now you can see in the database, we are seeing these three tables. This one we created and these two are the other tables. So we see the passport table. Passport has a ID column, number column. We see the student table. Student has a ID column, name column. So these two tables have got created because we have created two entity classes, passport and student. And we have not inserted any data into this table, so it's coming as empty. So if I copy this, a shortcut for running for this run button is Control Enter. It's the same thing as clicking this run button. So we can see that these tables are right now empty. So that's about the code walkthrough and functionality walkthrough of this application. Any doubt about this first hands-on? Anything that you have not understood about the skeleton application? This is the skeleton of it.
So what is @ data? We are yet to cover that, right?
No, we already covered it. I think you joined late. So @data is a Lombok annotation.
Okay.
It basically creates getter methods,
Getter,
setter
setter.
methods
Okay.
in the background. So you cannot, so you don't see it here, but if you check the outline of this class by pressing Ctrl O or by going to Windows Show View Outline, you'll see that we are having
Yes,
these
got
getter
it.
methods, setters and everything. Okay, if everyone is clear with the first hands-on, you can write clear in the chat and we'll proceed to the next hands-on. Is everyone clear? Okay, great.
Yes, clear.
Okay, after every 3 hands-on, we can take a 5 minutes break. So this was the first hands-on. This is the second hands-on. So let's make passport the owning side of the relationship. So as part of this hands-on, you're going to learn about how to use @1-to-1 mapping annotation in passport class, use of data.sql script to insert some records into the tables, fetch student out of passport, how we can fetch the student details out of passport. Demonstrate the default fetch type for one-to-one mapping is eager. So you're going to see that what is a default fetch type for one-to-one mapping, and it is eager. So you can remember one rule: anything to one is eager by default. The default fetch type for anything to one is eager. Default fetch type for anything too many is always lazy. So you can remember this rule, this as a rule, okay? And let me add this over here in the notes as well. So anything too many to one, first of all, default fetch type is always eager. Anything too many is always lazy. So remember this as a rule for default fetch type, and you'll never forget the default fetch type. Okay, after this, you're going to understand the use of @transactional annotation. So @transactional annotation is used for keeping the session open. Even if you don't fully understand the use of @transactional annotation as part of this hands-on, you'll understand it eventually as we proceed with other hands-on. PowerPoint is for teaching purpose, but you can have the code content. Like I'll be sharing the code with you. I'll be uploading the code onto the GitHub. Okay, then you're going to understand the meaning of unidirectional relationship. So in Hibernate, there are two types of relationship: bidirectional and unidirectional. You'll understand the meaning of it as we'll start the hands-on. Then you'll understand the terms such as owning side of relationship and non-owning side of relationship. So this is a kind of a Hibernate language. By the end of today's training, you'll be aware about this language, and you'll start talking with yourself using the Hibernate language while you're coding, and you'll not make a single mistake if you understand this language in today's training. Okay, so let's start. First is the use of @one-to-one mapping in passport class. So let's go to passport class. Let's add this annotation. So we are adding @one-to-one private student. What this will do is this will make passport the owning side of this unidirectional relationship. So if you have this mapping annotation only in one class and not the other class, that means you have a unidirectional relationship between passport and student. And if you have this mapping annotation in this passport class, that means passport becomes the owning side of the relationship and student becomes the non-owning side of the relationship, because student doesn't has this mapping annotation right now. So student is the non-owning side of the relationship between the unidirectional relationship that we have established between passport and student. What it really means to the database is, in order to understand that, we'll go to our H2 database and we'll see in the H2 database console, we'll see how the passport table now looks like, since we have added this additional variable here with this annotation. One more thing, I don't have to restart the application manually. Reason being, I have used DevTools. So DevTools automatically restarts the application whenever I make any change and I save any file. For example, if I add a space here, now you can see this file is not saved because I can see this asterisk symbol here. If I save this file, it will the DevTools will auto restart the application, and we can see in the console it has auto restarted the application for me. So it's still auto restarting. Yeah, it took 4 seconds, 4 point something seconds for this application to restart. Okay, since we have added this mapping annotation in our passport class, let's go to H2. Since we have restarted our application, we need to refresh, and you can see that previously we had created the test table here. Now this table will get deleted. Reason being, we are using H2. H2 is an embedded database. That means all the data persisted into this database is lost on application start. We are using H2 database because we don't want to deal with a database cleanup each time we are testing out a new concept. Okay, so now you can see again we have only two tables, passport and student. These tables have got mapped or created, you can say, from these entity classes. And since in the passport entity class we have added this one-to-one mapping and student, so if we expand this, we can see that in the passport table we have one additional column here called as student ID. And in the student table, we don't have any additional column. From where is the student ID column coming from? It's coming from this part. Since we have added this annotation and student variable here or student reference here in the passport, it is adding additional column in the passport table called as student ID. So student ID is a foreign key in passport table and it's a primary key in student table. And this ID is the primary key of the passport table and this ID is the primary key of the student table. So is it clear so far what this mapping annotation has done so far? Like what it does?
Yes,
Yeah,
Samarth.
so we use it for the class fields, right? I mean, for the passport class field, if there will be another field, we can use that for that as well, one-to-one.
Correct, correct. If you want to establish unidirectional relationship between two entity classes, then you use this one-to-one mapping annotation. What this unidirectional relationship means, you'll understand that as we'll go through different points of this hands-on. Okay.
So ideally, it won't be for all the fields, right? It will be for the primary key or the foreign key concept related only fields, right?
Correct. In a
Yeah.
unidirectional relationship, you'll only have a foreign key in one table. In a bidirectional relationship, you can have in two, but it is a bad database design. In order to fix it, there is an annotation which I'll be teaching you in the coming sessions, in the coming hands-ons.
Okay.
So don't worry too much. For now, just remember what this annotation does. This annotation adds a foreign key in passport table. This is step one. Just remember what it does. Now let's see the use of data.sql script to insert some records. Let's open the data.sql. Let's insert some. Right now, who's the owning side of the relationship? Right now, passport is the owning side of the relationship. Why passport is the owning side of the relationship? Because passport has this mapping annotation and student doesn't has this mapping annotation. So passport is the owning side of the relationship. So when passport is the owning side of the relationship, that means passport has a foreign key. If passport has a foreign key, then that means I need to first insert into the student table. Then I'll have a student ID. Then I can insert into the passport table because passport requires a student ID. So this will be the sequence of insertion in a unidirectional relationship between passport and student. Now that we have inserted some data and we have not saved this file, let's save this file and let's wait for the application to restart. Now application has restarted. Now let's go back to H2. Let's refresh this. Let's re-log in and let's see the passport and let's see the student. Yeah, my bad. So we can see that we have these two passports. We have passport with ID 1. Number is IND 100. We have passport with ID 2. Number is IND 101. And this is the student ID. So this passport IND 100 number belongs to Sam. This passport IND 101 belongs to Hiran. So this is how the mapping relationship has been established so far. Now let's fetch student out of passport. Now, which is the owning side of the relationship, students? Which is the owning side of the relationship here?
Here in this one, passport, right?
Correct. Passport is the owning side. So whichever is the owning side of the relationship, we fetch the non-owning side out of that. Since passport is the owning side, so first we fetch the passport details and out of passport, we fetch the student details. So using the entity manager, I have auto-wired the entity manager here. So using the entity manager, I'm fetching passport with ID 1 and then I'm printing it. So I've initialized logger with Lombok annotation @SLF4J. This is another Lombok annotation which has initialized the logger factory for me. And I'm logging it over here. So this will print the passport that we have fetched with ID 1. So we can see the passport with ID 1 and it belongs to student Sam. So we can see that when we are fetching the passport details along with passport details, it has also fetched the associated student details. You know why? Because the mapping between passport and student is 1-to-1, and anything that is 2-1, the default fetch type is eager. Since it's eager, so when you fetch the passport, it automatically fetch the associated student with it. Then out of passport, here we are fetching the student. Also, you can see that we are seeing the select queries and the join queries. So these are the queries which gets created in the background and executed in the background for executing these things. Now, if you don't want to see these big queries, so these are the big queries that we are seeing, and it's coming in a readable format because we have added these two properties. This property is making it in a readable format. If we don't want it in a readable format, we can set it to false. Now you can see, we can see the create table passport query here, create table student query here, and this is coming in one line, not much readable. Now, if you don't want to clog the logs and if you are facing some issue, then you can use these properties. So now I'm just setting the shows equal to false because I don't want to have two bulky console logs over here. So now you can clearly see we have fetched the student details and we have fetched like passport details, and out of passport we have fetched the student details. Okay, so we have done this one. And you have also seen the default fetch type for 1-to-1 mapping is eager. So when we fetch the passport detail, and when we printed the passport detail, it automatically printed the associated student detail because the default fetch type between passport and student is eager. Next is understanding the meaning of unidirectional relationship. So meaning of unidirectional relationship is that in Hibernate that we can fetch student out of passport, but we cannot fetch passport out of student. That's one limitation with unidirectional relationship. So if you want to fetch anything out of anything in your code, then you need to establish bidirectional relationship. And we'll come to the bidirectional relationship in the upcoming topics. Then you can see the use of @transactional annotation. So right now we don't need @transactional annotation. Reason being the default fetch type is eager for passport. So if a default fetch type is eager, we don't need to use @transactional annotation. When the default fetch type between two entity classes is lazy, then we need to use @transactional annotation to keep the session open. I'll show you what happens if you don't use @transactional annotation when the default fetch type in a method for two entity classes is lazy. We'll get an exception, no session exception, lazy initialization exception. And we'll see how we can fix that. Okay. Next is understanding the terms such as owning side and non-owning side of relationship. If I ask you what is the meaning of owning side and non-owning side of relationship, can you explain me now?
Yeah. So for owning side, if we use that annotation 1-to-1, so that establishes the ownership. And if other class also will have it, it will be the bidirectional one then.
Yeah, don't talk about bidirection. People will
Okay.
get confused. I'll come to
Uh-huh.
that in our coming topics.
Yeah,
You're correct,
whoever is
actually.
using.
Yes. Okay, that's right. So that's the meaning. So whichever class, whichever entity class has this annotation, so it has a student here, right? So it's the owning side of the relationship between the unidirectional relationship that we have established between passport and student. Okay, good. So we'll continue with the next hands-on. So we have covered this. Let's cover this one, change relationship. So last we had made student the owning side of the relationship. Now let's change the owning side. Let's make I mean, last time we made passport the owning side, right? So now let's make student the owning side and passport the non-owning side. So let's go back here. So if we want to make student the owning side, we need to add this annotation here. If we want to make passport the non-owning side, then we don't add any mapping annotation in the passport. This way we can make student the owning side and passport the non-owning side of relationship. Now next thing is, let's relog into the database. Okay, since we changed the owning side and the non-owning side of relationship, we also need to modify these things over here. So let's insert the data when student is the owning side. So when student is the owning side, student will have the passport ID, but passport will not have the student ID. So we'll first insert the non-owning side and then the owning side. Now let's log into the database. Let me check what is breaking now. Yes, one more thing. Since we have changed the relationship, we need to uncomment this and comment this out. So we can only fetch the non-owning side. 1 minute, what is the problem now here in this class? There is some issue. Yeah, I have not saved this class. That's why. Okay, so we can only fetch the non-owning side out of the owning side. So what we have done is we have made student the owning side and passport the non-owning side. Then we have inserted passport first, because if student is the owning side, student will have passport ID. That means we first need to insert passports, then we can insert students. And we have changed over here also. So here we are fetching the student using entity manager, student with ID 1. And here we can see we have fetched student with ID 1, which is Sam. And we have fetched passport of Sam, and the passport of Sam is this IND 100. We can see the same in the database also. If we log into the database, if we execute these queries, so you can see that student has a passport ID, but passport doesn't has a student ID. So what do you understand from this? This means that student is the owning side of the relationship and passport is the non-owning side of the relationship. So whichever table has a foreign key, that is the owning side of the relationship. And whichever table doesn't has a foreign key, it's the non-owning side of the relationship. So as part of this hands-on, you have seen how we can make student the owning side of relationship, how we can fetch passport out of student. So here we have fetched passport out of student. Then you have understood the meaning of unidirectional relationship. If student is the owning side of relationship, that means we first need to fetch student, and out of student we can fetch the passport, but not the vice versa. Then you have understood the terms such as owning side and non-owning side of the relationship. If this hands-on is clear to everyone, you can write clear in the chat, then we can proceed. What about
Can you
others?
just talk
Yeah.
about this entity? I mean, how are you using this? If you show me the class, not this one, the other one where you are fetching the data actually. Entity manager. Yeah, if you can talk about that a little more.
Okay, so we can use entity manager. So internally, you have seen JPA in the fundamentals training, right?
Yes.
So JPA also internally uses entity manager. It's a wrapper over entity manager. So I've used the inner thing, entity manager. Using this, we can fetch these things. So this is what JPA is built on top of.
Okay.
So using entity manager find method, I fetch student with ID 1. Okay. Now, okay, I think it's everyone's clear. Guys, since very less students have joined, if you want your friends to learn from this training, you can share this training link with them. You have the training links, right?
Yes.
through which you have joined. Just share it with your friends, whoever is in the IT, in the Java. Okay. Moving on to the next hands-on. Understanding the eager fetch and lazy fetch. Let's understand the default fetch type for one-to-one mapping. If you remember, I've given you one rule to remember this always. If anything that is 2-1 is the default fetch type is always eager. This is the rule which you can remember. Anything that is too many, like it can be one too many too many, is always lazy. We can change the default fetch type, and you're going to learn as part of this hands-on how we can change the default fetch type. So default fetch type, since we are learning one-to-one mapping, it's eager. So we'll change it to lazy. And we'll see that whenever there is lazy fetch, we need to use this @transaction annotation. Without it, our application will not work properly. So let's, okay, we need to have lazy fetching. And right now, student is the owning side of the relationship. So let's add this. Let's add this. So what we are doing now is, I've just added this thing additionally. So in the one-to-one mapping, I've added fetch type, lazy. So by default, it was eager. And we can see our application start has failed. Let's see what problem it is saying. It is saying lazy initialization exception, could not initialize proxy entity class passport, no session. You know why we are getting this? On which line exactly are we getting this? So we are getting this on this line because when we are fetching student, so you can see we were able to fetch student, but when we tried to fetch passport, it has failed because of two reasons. First is a toString issue, and second is no session. Let's fix the no session issue by adding this @transactional annotation on top of this run method. So this run method is a override method. So since we are implementing command line runner, anything we write inside this run method will be executed as soon as the application starts. And Spring Boot application starts after the execution of this line. In interview, sometimes you'll be asked if you have sys out here. And if you have a sys out here, which one will be executed first? You might be asked this question. So the answer is this will be executed first, because whatever you write in your run method gets executed as soon as your application starts. So application starts when this line is executed. Let me demonstrate this. So we use command line runner for quickly testing our functionalities. First, you can see I'm not getting that exception anymore because I've added @transactional annotation. And next you can see it's printing run first and then main. It's printing this run first and then main, because as soon as this application starts, and this application starts when this line is executed, whatever you have written here, this gets executed, and then the pointer comes over here and executes this line. Okay, that was just for your interview question, because sometimes in interview you'll be asked this question. Now going back here, so you have seen that we have changed the default fetch type for our one-to-one mapping annotation to lazy. Where is it? Right now, student is the owner. Student is the owner. So we have changed the default fetch type by adding this fetch attribute to @one-to-one mapping annotation. So this is the attribute, and this is the enum of that attribute. So we are assigning the value lazy to this fetch type. And whenever the fetch type is lazy, we'll have to add @transaction annotation to keep the session open throughout this method. If we don't add this annotation, it will close the session as soon as this line is executed. So when this line gets executed, it will not have a session open with the database. So it will throw that no session lazy initialization exception in your logs. You'll see that error. So in order to fix it, just add it. It will keep the transaction open throughout this method. Okay, so any doubts about this?
So we were getting two exceptions. One we fixed using transactional.
Correct. And
And
the
the
toString one,
two
another
string one
one.
also
Good
got it
question.
fixed.
Yeah, I think I've created my custom toString to avoid that. Correct. So see, by default, since we are using Lombok @data, so @data will create a toString method which will print all attributes of this class, ID, name, as well as the passport. But since the default fetch type is lazy, that means that on this line, when we fetch the student details, it will not fetch the passport details. It will only fetch the student details. On this line execution, it will actually fetch the passport details because we have changed the default fetch type to lazy. Now, if you want to see the toString issue, let me show you the toString issue. If we are using Lombok, it creates a all args toString method, which prints out everything like this. And to overcome that, I avoided printing out the passport. So if I remove this, again by default, it will use the Lombok toString, and Lombok toString has looks like this. So it will try to fetch everything. And in order to get the problem again, I'll have to go here, comment out this. So if I comment out this, since I have made @transactional, so it's not giving this issue here. But if I remove this, we'll see this issue again. We'll see both the issues again. No session and toString issue. Where is the toString issue? Okay, it's caching something, I believe. Here it is. See, toString issue. So in order to fix these issues, I've first of all, in order to keep the session open to get rid of the lazy initialization exception, I've added @transactional annotation. And to avoid the toString issue, which I'm not getting here, I have added this custom toString method. So right now we are not getting this toString issue, but you might get it. So it's better to have a custom toString method and to avoid printing the associated entity class when you're using Hibernate. If you get that, just remember this as a solution. In the later versions of Spring Boot, like 3.0.2, we are not getting this issue, but in the prior versions till 2.6.7, I've seen this issue. Okay, any doubts about this, or is it clear to everyone?
Yeah, got it. So what's the I mean practically use of this lady and eager fetch type?
Yes. So it's a programmatic design, how you want to design your application. Let's say you are fetching a student detail. It's having, let's just an example, okay, hypothetical example. You're fetching a student detail and it's a very big row, and the address, let's say it has something like student address. Okay, student address. So a student address, let's for hypothetical reason, let's say the address is a very big huge value in that column. In the address columns field, in that cell, you have very huge value, and you don't want to load everything. You just want student name and mobile number and not address. Now imagine if you're fetching and processing 1 lakh students. So will you be fetching unnecessarily their addresses, or will you be using lazy fetching here? So you only load the student details and not the associated address details.
Okay.
So it's a design thing, like how you want to design your application. how efficient you want its processing to be. So use lazy fetching as much as possible so that you efficiently utilize your JVM memory. Okay, coming to this one, hands-on. Implement bidirectional relationship, make student the owning side of the relationship and the toString issue and its fix. So we are not seeing this issue anymore, but if we see, we can see the fix. Now we are going to implement bidirectional relationship between passport and student. So we'll implement bidirectional relationship between these two entities. We'll make student the owning side of relationship. We'll see the issue with generated toString method, or we might not see this issue in the later version. So let's see if we are getting this issue. I mean, in unidirectional relationship, we have seen that we didn't really need this custom toString method that I've added here, but I think in bidirectional it breaks. Okay, so we want to establish bidirectional relationship now. Always take both your entity classes like this so that you have clear idea about things. Now we want to have bidirectional relationship. So we have this already here. Let's add this also here. Now we have added these two things over here and we want to make bidirectional relationship. So, okay, let me show you the problem. If you add one-to-one mapping in both of them, you'll see one issue, but that is what is required for bidirectional relationship. And I'll show you then how by using mapped by attribute, you can solve that issue. So right now I have created bidirectional relationship between student and passport. And here you can see it's saying null over here. Okay. So now we have established bidirectional relationship. Let's refresh this. Let's see how the tables look like. So in passport table, we have student ID. In student table, we have passport ID. This is a very bad database design. I'm just demonstrating so that you understand the concept, but I'll teach you the good database design. Okay. So this is a bad database design, what you see here. It's not a good thing to have foreign keys of each other in two tables. Okay. Now in order to fix this, we want to make student the owning side of the relationship. So we want to make student the owning side of the bidirectional relationship. So how do we make student the owning side of the relationship here? We make student the owning side of the relationship. This is a student class. We make the student the owning side of relationship by adding @1-to-1 mapping. Like, I mean, it was before also, but by adding this mapped by in the passport. So remember this as a rule. We use mapped by attribute of any mapping annotation to mark that particular entity class as a non-owning side of the relationship. So I'll add this rule also over here. Just remember these rules and Hibernate will remain at your fingertips for life. Okay. So, okay. So can you tell me what I've done now by comparing both the classes?
So we put it as a fish type as a lazy load, and then using map by annotation, we on a non-owning side. We made passport on a non-owning side.
Correct. And student is the
Owning side.
owning side. Correct. Whichever is the owning side, it will have what? A foreign key. So student will have which foreign key? Passport
Passports.
ID.
Right. Passport ID.
And the non-owning side doesn't has a foreign key. Let's see this in action. Let's refresh this now. So we can see that passport has a student ID. Since passport is the, I think something has went wrong. The application didn't start properly. So we have marked passport as the non-owning side, student as the owning side. Our application has not restarted properly for some reason. Let me restart it again. So I think some caching issue had happened, because of which application didn't restart.
So we are expecting passport should not show any student ID.
Correct. Because it's a bidirectional relationship, and we have mapped one side as non-owning side and other side as owning side by not using this over here. The student is owning, passport is non-owning side. Let me refresh. Yeah, so now it's correctly coming. It seems like DevTools had not properly restarted the application before. So now we can see passport doesn't has a student ID, student has a passport ID. Why student has a passport ID and passport doesn't has a student ID? Although we are using this mapping annotation in both the classes, it's because we have used this mapped by to mark passport as the non-owning side. So whichever becomes the non-owning side, it will not have a foreign key. So passport doesn't has a foreign key, but student is the owning side, so it has a foreign key. Now since student has a passport ID, we need to insert it also that way. So we need to insert, now student is the owning side, so we first insert passport and then we insert student, because student requires passport. Is it clear to everyone what happens and how we establish bidirectional relationship?
So in the map by we mentioned the reference ID of the other one, or how is it?
Correct. We
Of the
copy
student.
this. Yeah.
Yes. Okay.
We
Okay.
copy this from student class and we paste it as it is over here. It should be as it is. Even if you miss a T, it will not work. If you write it like this, it will not work. It should be exactly, just copy this from here and paste it here always. Okay, so this is done. We have set the fetch type as lazy and we have not got any toString issue. So with this, we have done this one thing, but there is one more thing I would like to demonstrate. Since we have bidirectional relationship, so the real meaning of bidirectional relationship in Hibernate means we can fetch anything out of anything. So we can fetch passport out of student, student out of passport. Let's save this and let's see this in action. So we are fetching student of ID 1 and passport associated with that student. Then we are fetching passport with ID 1 and student associated with that passport. And we can see in the logs, it all works. We fetch student and passport out of student. We fetched passport and we fetch student from passport. So if you establish bidirectional relationship between two entities, then you can fetch anything out of anything. But when you establish bidirectional relationship between two entities, that adds a foreign key in both the tables. And we don't want a foreign key in both the tables. That's a bad database design. In order to fix that bad database design, we use this mapped by attribute to mark a certain entity class as a non-owning side of the relationship, or we can say as a non-owning side of the bidirectional relationship between two entities. So is it clear now to everyone what's the meaning of it?
Yes, Samarth.
Yes, but we made it this passport as a non-owning site. Then still we are able to fetch the data as you said.
Correct. Yes, because the relationship between passport and student is what? Both the entity classes have each other's reference. Both
Right.
have each other's reference. So this is a bidirectional relationship. In a bidirectional relationship, you can fetch anything out of anything. But in order to avoid that primary key, in order to avoid the primary key of student ID in passport table, we have added this. So this removes that student ID from passport table so that we don't need to maintain the mapping in both the tables. This allows us to fetch in any order, but doesn't allows us to enter in any order. We still have to enter passport first and then
Passport
student.
first. Yeah.
Okay, so this explains the one-to-one mapping. Let's take a 15 minutes break now. and after that we'll continue with the next one, which is one to many and many to one. And after this we'll continue with MicroStream. I'll give you a walkthrough of a MicroStream project which I have created using the latest versions, and then we'll in the end do the Hibernate. So this is the upcoming topics. I'm closing this PPT. Any doubts with one-to-one mapping, or is it all clear?
It's clear.
So this is another course in itself, Spring Boot Hibernate, one-to-many and many-to-one mapping. 1 minute. I see Dheeraj couldn't join. I think he'll resend his request. Okay. So I provide you walkthrough of the provided Spring Boot application. So let me close this previous application. I'll be committing I'll be committing all this code to the GitHub repo, post all the explanations. So this
Samarth, I
is
have one small doubt.
Mhm.
Like
Go ahead.
in this application, we in single application only we have a student and passport. And suppose if
Correct.
we create like two different microservices, for one for student and one for passport, and we want to do the same thing like mapping, is it possible
Good
in that, like
question.
in two different microservices, and both the microservices are connected to same database?
Tricky question. I've never tried it. I'm getting your point.
Mm-hmm.
I mean, how will it work is something. I think in that case, what you'll have to do is you can try that out,
Mm-hmm.
create two different projects with two different entities, and you'll have to import the other project. So you'll have to package your student project in your
Mm-hmm.
Hibernate and Hibernate project in your student, because otherwise, if you don't have this class here, how will you get it?
Yeah. But
So you'll have
what I
to
thought that the main objective of like microservice is to that to be independent.
correct, correct.
That's why we are doing here only.
Correct. I mean, no, we are not. I mean, in real applications, it can be multiple entity classes. But
Yeah,
what
yeah.
your question is a very
Mhm.
unique case. But if that
Yeah,
happens, what you'll have to do is you'll have to import your project into this one so that you can use this class, which will be in another microservice. You'll have to basically package your other microservice and add it as a dependency in your
yeah,
POM.
in the class path.
Correct. In the class part, packages should be available here.
Okay, okay.
But it's good. I mean, innovative thinking.
Mhm.
It's a unique case, but it rarely is required. I mean, this kind of thing is I've never come across. But yeah, I mean, it can happen in very unique scenarios, business use cases. Okay. Next is many to one and one to many. So let's again start with the POM file. Again, we're using the latest version of Spring Boot 3.0.2. One more thing I forgot to mention. With the latest version of Spring Boot from 3.0.0, it's mandatory that you have to use JDK 17 and above. You cannot use JDK 8 with 3.0.0. So I've already explained this in the fundamental training, but if some of you have not attended my fundamental training, so this is for you guys, that we cannot use JDK version lesser than 17 for Spring Boot version 3 onwards. Here again we have JPA dependency, DevTools dependency, H2, Lombok, and I think I've added Lombok twice by mistake. Then we have the web dependency, and what others we have? Yeah, web dependency and this starter validation dependency, and the Swagger UI dependency. I've added the Swagger UI, but I've not built the Swagger UI here. So this dependency is not really required. So I can get rid of this. This was also not required in one-to-one Swagger dependency because we are not using Swagger UI. This is the um, this is the main resource directory, resource directory, base package, entity package. This is the main class. Again, we have auto-wired entity manager, uh, instantiated logger with Lombok annotation @SLF4j. And we are going to comment, uncomment these things as we go through different topics. This is a course class. Course has a ID, course has a name, last updated date, created date, and we have so far not used anything. We'll use all these mapping annotations as we'll go through different topics of this course. Then we have review. So course can have multiple reviews. So we have a review class here, and review has a ID, has a rating, has a description. Then again, we have application.properties. We have instantiated, we have configured our H2 database. These are all H2 configurations. And again, this is for data.sql. And we have the banner text. So whatever you write here in banner.txt file, when you place it in this path, whatever you write here, you'll see this instead of Spring Boot when you start your application. So let's see this. Okay, so our Spring Boot application is starting, and we can see that on start, we have seen this, whatever we have written here. Now, next thing is, let's see these entity class mapped tables in the H2 console. So let's go to our H2. Let's refresh this. Let's connect. We can see the course table, the review table. Course has a ID, created date, last updated date, name. Review has a ID, description, and rating. So this was about the code walkthrough and functionality walkthrough. If this first hands-on is clear to everyone, you can say clear in the chat, and we'll proceed with the next hands-on. This was just again the skeleton walkthrough. Okay, thanks. Okay, let's start with this hands-on. Create relationship between course and review and insert values with data.sql script. So as part of this hands-on, we are going to use @1-to-many and @many-to-one mapping annotation. We're going to make review the owning side of relationship. We're going to insert values in course and review table with data.sql. So let's first learn the use of these annotations. So let's use these two annotations. So let's go here. Let's go to the course. Let's go to first review. Let's add this over here. This will add a course ID in review. And let's create a bidirectional relationship. So we are adding this 1-to-many. So one course can have many reviews. Since it is too many, it's also the default fetch type is lazy. And also another thing is, since it's too many, you need to use array list or hash set, basically a list or a set here. You cannot use simple reference. You need to use list of something. Okay. Next is in review, we have added this. In course, we have added this, and we have marked course as the non-owning side of relationship by adding mapped by course. And this course we have simply copied from here and pasted here. That's all we have done. Now let's see how it looks in the table. So we have seen the use, like we have added these annotations, and we have made review the owning side of the relationship. So we have made review the owning side of the relationship by adding this mapped by in the course annotation, course class, this attribute annotation. Let's refresh. Let's see the table structure. Okay, let's see from here. So in course, we have no additional foreign key. In review, we have a foreign key course ID. So right now we have bidirectional relationship between course and review, and course is the owning side, review is the non-owning side. Review is the owning side, course is the non-owning side. And since review is the owning side, it has the course ID. And since course is the non-owning side, it does not has the review ID. And to make course as the non-owning side, we have used this mapped by here. Now, let me tell you one thing. Why have we directly created a bi-directional relationship and not unidirectional relationship here? The reason is it's a bad database design to have review IDs as a column, because for review IDs, you can imagine this course can have thousands of reviews. What will happen when this course has thousands of reviews? That means in this cell, column cell, there will be thousands of comma separated values because it's a list. So it's a bad database design. In order to avoid the bad database design, directly we have created a bi-directional relationship between course and review, and we have avoided having comma separated values. And we know that wherever there is an array list as a reference, there will be comma separated values. So we have just marked this field as not required by adding this mapped by. So this basically removes the review IDs column from the course table, so that we don't have to have a bad database design. So now you understand why we have directly created bi-directional relationship here, why we don't want review IDs here. Because you can imagine the insertion. It will be multiple comma separated values for review ID. So it will be a bad database design. So we didn't wanted a bad database design. So that is why we have made bi-directional relationship, and we have made review the owning side of the relationship. Now let's insert values in course and review. Since review is owning side, so review has a course ID. That means first we need to insert the non-owning side. So let's insert the non-owning side and then the owning side. So first we are inserting a course with these things, with ID 1, current date, this created date, updated date, and the course name, which is Spring Boot Hibernate. Then we are inserting into review table ID, review comment, which is best course on Hibernate, rating, and for which course it is. This is for this course. This review is for ID 1. Now let's refresh this again. Since we have made changes, I believe I've saved my file, right? Yes, I've saved it. Okay, let's execute these queries. Let's see the data in these queries. So we can see that in course table, we have Spring Boot Hibernate course with ID 1.
माझा class आहे.
And in review table, we have best course on Hibernate with rating 5 and course ID 1. So is it clear now what we have done, how we have inserted data? Like why, first of all, we directly created a bi-directional relationship here, and how we made review the owning side of this relationship. And then how have we inserted values by using data.sql. Any doubts so far about this hands-on, or is everyone really clear?
Samarth, can we make only unidirectional by using many to one only?
Yes, we can. But it will be, let's say, many to one. So you want to have this. Let me just copy this, comment this, go below, paste this, remove this. Let me show you what can go wrong. Let me show you how does a bad database design looks like. This will be a bad database design now, because it's, first of all, it's because of this, the array list here. Now, if we go here, refresh, login. Now you can see we have a join table. You see this join table?
Yes.
We'll have to maintain data in this join table. So yeah, I remember one more thing. Anything which is too many will lead to a joining table, many to many or one to many. So you'll have to maintain the details here. So Hibernate is designed to avoid the bad database design. I mean, if you make it bi-directional, then it doesn't has this join table. So in order to get rid of this join table, because you can imagine it's again also a bad database design, because one course will have multiple IDs. That means there will be comma separated review IDs into this. And we want to avoid having any comma separated values or multiple big values in one cell of a database. That's a bad database design. So in order to avoid this bad database design, we came up with this approach that we directly established bidirectional relationship between course and review, and we made review the owning side and course as the non-owning side, and then we inserted value into it. So we first insert into the non-owning side and then into the owning side, because the owning side has a foreign key course ID. So if it's clear,
Clear,
is it
Samarth?
clear? Okay.
Yes, sir.
Okay, now you really understand, right? Why I have not implemented unidirectional relationship, because it leads to a bad database design. I mean, join table is not really a bad database design, but the column inside that join tables, which we saw, the reviews column, reviews underscore ID column, was a bad database design, because we don't want to have any comma separated values in any column of a database. That's a bad database design. Right now, what we are having here is application first database design, because we are designing our database tables directly from entity class. This is called application first approach. Okay.
So now multiple reviews will be in the review table itself because it's owning it, and then it's made into one, and okay. Mhm.
It will only have in the one cell, it
One
will only have
value,
one course ID
one course ID,
and
right?
not any comma separated. So we
Yeah,
just want
and
to
even for
avoid comma
multiple
separated.
reviews on a one course, it will have multiple
Multiple
entries in the
rows.
database, multiple rows. Yeah.
Correct.
Yeah.
Correct. Correct. So this is a proper database design to avoid insertion of too many values in one cell. Okay, so this is done. Let's go to this one. Retrieving course and its reviews and understanding the default fetch type for one-to-many. So as part of this hands-on, what we're going to do is we're going to retrieve course details by using entity manager, the find method which you have seen before. Then we're going to retrieve review details from the course details. We'll understand the default fetch type for one-to-many. Anything that is too many, the default fetch type is always
Lazy.
lazy. Correct. So remember this rule. Okay, let's do it. Let's go to the main class. We have auto-wired the entity manager. Right now, who's the owning side? Right now, review is the owning side. I mean, it's a bi-directional relationship, but review is the owning side. So it doesn't matter. We can fetch anything out of anything because it's a bi-directional relationship between course and review. Whenever there is a bi-directional relationship, by bi-directional, I mean the mapping annotation is present in both of the entity classes, we can fetch anything out of anything. So let's first do this hands-on, where we first fetch course details and out of course review details. So we are fetching course details. Course has what kind of relationship with entities? It has too many. Means default fetch type lazy. If it's lazy, then we need @transactional.
Transaction.
Since we have not added @transactional, we'll see this lazy initialization exception. No session. We can see here that when we were fetching the course details, it had successfully fetched the course details, but the application throwed this lazy initialization exception on execution of line number 34 on get reviews, because we have default fetch type is lazy for course to review. That means when we are fetching the course details, it will not by default fetch the review details. And the database transaction is only open on execution of this line, on entity manager line. The database session is by default closed after the execution of this line. If you want to keep the database session open throughout the execution of this method and to get rid of this lazy initialization no session exception, then we need to add this @transactional annotation. This will keep the transaction open throughout this method. So we can now see that it will fix the issue. And we can see that it has fixed the issue. We have fetched the course details and we have fetched the review details out of course details. And you can also see one more thing. When we are fetching the review details, along with review details, it has also fetched me the associated course details. You know why? Because the default fetch type for anything that is to 1 is what?
Eager.
Eager. Correct. Now if you want to change it, experiment around. If you want to make it lazy, you can try that. But since we have this @transactional, still it will fetch. So it will still fetch. But if we remove @transactional now, then this line again will break because the database session is closed. So in that case, what can we do? Yeah, I mean, so we cannot do anything because you understood the loop, right? So if I remove this, the database session won't be there, so it won't be able to fetch this. And if I don't want to print these details, it has already fetched the student course details, right? So it's simply printing it. But if you don't want it to again fetch, okay, it again fetches the course details here. So if you don't want it to again fetch the course details, in that case you can create a custom toString method and avoid printing the course details. That is how you can avoid fetching the course details again.
Yeah, like
It's
the
little
one you
tricky
did it
to
in earlier
understand.
example, I guess.
Correct. Correct. I know it's little tricky to understand what I just explained, but it is that tricky concept that you'll eventually get the hold of it. Just remember the rules, keep note of these rules, which I have written in the previous project. And these rules will keep hibernate at your fingertips. You will not make a single mistake while coding, while creating mapping classes. Okay, so we have done this, we have done this, we have done this, we have done this. Okay, before we proceed to next hands-on, do you have any doubts about this hands-on?
So when you actually work on these projects, you use these things. Uh,
Okay, good question. So while I was working in Accenture from and here technologies like 2-3 years ago, so that time I had used these things. I had used Hibernate for creating the mapping annotations. So this is really used in the banking projects, financial projects, and other Java based projects. But this knowledge you can also use not just for your office work, you can also use for building your own product. Why just to think of office work, right? Gain the technical knowledge, build your own product, create job opportunities.
mm,
So knowledge is the main thing. Okay, so this is done. We'll come to this one. We'll take a quick 5 minutes break because we have done 3 hands-on back to back. And after that, we'll do this last hands-on of this one. And then we'll continue with MicroStream. I'll explain you what is MicroStream. And then we'll continue with many-to-many mapping annotation. Hands-on. Retrieving reviews and its associated course and understanding the default fetch type for many-to-one. So as part of this hands-on, we're going to retrieve review details by using Entity Manager, and we're going to retrieve course details from review details and understand the default fetch type for many-to-one relationship is eager. And you should also remember the rule: whenever there is lazy fetching, we need @transaction annotation, and the default fetch type for anything that is to 1 is always eager. So let's fetch the review details and print it. And then out of review details, let's fetch the course details. So we are fetching course out of review. So what is it? It's eager, because if whenever we are fetching review detail, it will automatically fetch the course details along with the review detail, because here we can see it is 2-1. That means the default fetch type of this attribute will be eager. So if it's eager, we don't need @transactional annotation. So we can get rid of this. I'm just removing this so that I can show you that we don't need @transactional annotation here. So you can see that I've retrieved the course details. I think I've made a mistake here. Retrieve review details, retrieve course details. That's it. Just in the printing. So here you can see I'm not using @transactional annotation, but still I'm not getting lazy initialization exception, because first I'm fetching review, and review we can see has 2-1 kind of relationship with course. That means eager fetch by default and we have not changed the default fetch type also. So we were able to fetch the review details and we have printed the review details. Here in the review details, we can see along with the review details, it has also fetched the associated course details because the default fetch type is eager. And then out of review, we have fetched the course details. Basically on this line itself, it fetches the review details and the associated course details. And if you don't want it to do that, in that case, you can change the default fetch type over here from by default eager to manually to lazy. So is this clear to everyone what needs to be done here? Like what we have
Yes, sir.
done and what can be done.
Yes.
Okay. Okay. Any doubts?
So already if that is fetching in the code, I mean, in this first line is only fetching the record, right? The due to eager fetch, not this one, the other one where we are printing. So that's again from the yeah, that log info, first log info is itself actually also giving the course details, right?
This one, yes, this line is fetching the review details and also its associated course details automatically because we have not changed the default fetch type.
Hmm.
And default fetch type for anything that is 2-1 is eager. So here, since it's having eager fetch type for this course attribute, so whenever we fetch any review, it will automatically fetch its associated courses. So if it's fetching everything in one go, that means it already has the course details. We are simply printing a subset of the
Right.
details which is already fetched. So we don't need
So
transaction
this
annotation.
get course is user written defined method. I mean, user has written it.
Yes, we have written it. We have written it by using Lombok annotation @data.
Oh,
It
okay.
creates the
Okay.
getter methods.
Hmm.
Okay. So any doubts so far?
No, Samarth.
Okay, if no doubts, then since we had talked about products, let's first let me show you some products which I built in past. So I think this one. So I had built this product. It allows you to increase your Instagram followers using Spring Boot. So I had created, this is a private repository. So this is the product. So I'm not giving the source code access to anyone. So you can just imagine with the knowledge, you can do anything. You can build APIs, you can sell APIs, you can get definitely a job is the last thing that you would like to do. So get a job and you can create these APIs and sell it, wrap it with the UI, create a social media product or create a product to help others. I'll show you what all things are possible. So here you can see I had created these APIs. This allows me to get my followers, get my followings on Instagram, unfollow who do not follow you. A sweet revenge. In one shot, you can do that. You don't need to manually open and check. Unfollow a particular username, unfollow all these usernames. This username following, get someone's following, get someone's followers, follow all the particular usernames. So you can play around with the SDKs that are available and create your own tools or own products. Now, next product which I have created is it was for helping people, which is this coronavirus tracker. So during COVID, to help people track the COVID cases, it's a public repo. I had built one coronavirus tracker application and this has a UI. So I remember I had built this UI using the Thymeleaf dependency. It's not a good practice to use Thymeleaf, by the way. You should use Angular or React for building the UIs or proper UI technology. So I had deployed this product onto back then PCF Cloud, Pivotal Cloud Foundry, and had made it available for the people for a few months until I had that free credits of that cloud. Okay, one more thing is, right now also in market, if you think, there are a lot of products that needs to be built. It in cloud technologies are also evolving. I see a lot of limitations while working as a technical architect with various cloud technologies and microservices. One of the limitation I see right now, there is no product right now in market for automatically, let's say, migrating. How many of you are aware about Terraform, which is infrastructure as a code? Is anybody aware about Terraform here?
Yes.
So there are no tools for migrating Terraform to Pulumi and Crossplane. Right now, everybody uses Terraform, but in future, people can move to Crossplane or can move to Terraform also. Oh, someone has created a video. I was thinking of this thing of creating this video. I have a comparison document which I've created. So see, migrating from this, it's a manual process, but so far nobody has created any particular utility which will allow us to, automatically take the entire Terraform modules or custom modules or Google modules or any modules and automatically convert them to Pulumi code or Crossplane code. So these are few of the things which are, needed in the market but not builded. And there are a lot of other things also which requires to build it in the data ecosystems, but companies are now slowly building each and every functionality. Okay, so that was about the products and the ideas that I have, and also thinking myself to start building a utility which will convert Terraform modules to Pulumi modules and to Crossplane as an open source project where others can also contribute. Okay, coming to, and I think that would require using shell scripting, because we'll have to read the code and basically use a shell scripting and convert the code into Pulumi code. So that will be more of a migration project. I have an idea in mind, but I mean, we can get started. If you would like, I would share it on my LinkedIn if I start someday and you guys can start contributing. Okay, let's move on to the next one. So before moving to many-to-many mapping, we can learn about MicroStream. So MicroStream is a next level serializable framework. It overcomes the drawbacks of the Java serializable framework. So let me show you. It's a technology which is a next level serialization technology. It allows you to store any kind of object, Java object, to your targeted data store. Okay. So before we start, let me tell you this. This training is funded by MicroStream and JavaPro. So if you like this training, if this training has added value to your career or will add, you can just always drop a LinkedIn post, tag JavaPro and tag MicroStream and tag me for tag JavaStream and JavaPro and MicroStream for funding this training. Okay, let's start. So we all know that Java is a predestined environment to realize high performance in-memory data processing, right? What is the meaning of in-memory data processing? In-memory data processing means querying the data which is loaded in your RAM. That's called in-memory data processing. Or processing the data by loading into your RAM and then processing it and then storing it back to the database. So we all know that Java is a predestined environment to realize high performance in-memory data processing. So Java provides a first-class native multi-model data structure, which is called as Java Object Graph. So all the POJO classes that we create here, this entity class, also a POJO class, whenever we create an object of course, it gets stored as an object graph in the memory, in the RAM or in the JVM heap memory. So we realized that with Java, we can design our object graphs freely. We can adapt it seamlessly to our business requirements. We can create any kind of custom classes and use it as a data type. Like we can create any kind of custom classes and use it as any kind of data type. It offers complete flexibility. Basically, we can use any Java type, native multi-model data structure. We can use collections. We can use object references. We can use circular references. We can use inheritance. We can use third-party libraries. Only one data model, that is POJO classes. What's the query language to search Java objects loaded in the RAM? It's Java Streams API. We can use Java Streams API for querying the objects which are in our RAM. So this is the query language for MicroStream. So we can use Streams API for querying the objects in the RAM. What about persistence? So this is our application. This is generating or creating objects which is stored in the RAM. Then we store it in the database. So in order to store it in the database, there is a conversion layer in between, which is called as ORM mapping, object relationship mapping, which is a data conversion layer. So one of you had asked me this question today, that why do we require this dialect? So this dialect is required for configuring this conversion layer that we see here. So that is what is, so it tells that this conversion needs to happen for H2 database. We need to convert this object graph so that we can store in H2 database. If we want to store in MySQL database, then we need to add a MySQL dialect here. Then it will know that, okay, it needs to configure this conversion layer or ORM layer for mapping this object graph to a MySQL database or a Postgres database, depending upon your dialect and your targeted data store or database. So what are the challenges in this approach, in this legacy approach that we have right now? So the storing objects into tables, JSON, key value store, graph is always a data conversion which is required for every single read and write. So you can see that whenever I'm getting objects from the H2, there is always a conversion which is required. This does that conversion and stores that review details back to the object graph in my RAM. So it requires a lot of CPU power, reduces our performance, expensive latencies, complex architecture, expensive development process, inefficient concept, requires expensive cloud infrastructure because you know the database cost. I just saw one of my student had created a MySQL database using SQL database service on Azure, and his bill came around 173 pounds in a month for just, I think, 36 or 37 GB of storage. So the storage is generally costly. This kind of database storage is costly, so it increases your cost of infrastructure. And if you're thinking that, okay, in order to reduce the number of read writes from an database to have more faster read and write, what I can do is to reduce latency. I can add a caching layer. That is what people do. But even though the conversion is still required, which is an expensive operation. So we can see this conversion is always required. Now, if you're thinking of using NoSQL data structure, even object-oriented or graph database are also incompatible with native Java object graph. So if you're thinking of using these things, they're incompatible with Java object graph. So this is called impedance mismatch. So this is a system prevalence problem, that what you see here. You cannot directly dump your object graph to your targeted data store. There is a conversion layer which is required. The other problems with system prevalence is the various weaknesses and challenges. The snapshot time is one of the weakness. Snapshot size, time, long system, restore time after restart, not suitable for microservices, risk of losing data between snapshots. This is always there. Max DB size, less than RAM size, this can also be a problem. Let's say you are loading a table data into RAM, and that table itself has has 1 TB of data, but you don't have 1 TB of RAM, you have only 10 GB of RAM. So this is also one of the problem. That's where it's recommended always that whenever designing your application, use lazy fetching as much as possible. Big RAM size is required. Extremely huge traffic, high infrastructure cost, garbage collector issues leads to latencies, class changes, evolution, Java serialization, limitations and issues. So what MicroStream does? MicroStream eliminates the weaknesses of initial system prevalence concept. So it basically removes its limitations because it removes the data conversion layer itself. What happens now is, rather than having that data conversion in place, what MicroStream allows you to do is directly pick the object graph, which is nothing but binaries in your RAM, and dump it to your targeted data store. How you do that? You do that by adding a MicroStream library in your POM file or the dependency in your POM file, and you get this MicroStream, you configure this MicroStream, and using the MicroStream library, you can directly dump your object graph to your targeted data store. So it eliminates the conversion. It makes the infrastructure simple. It has faster time to market, saves a lot of vCPU power. Why vCPU? Because generally when we are talking about cloud computing, we have the concept of vCPUs. Minimizes latencies, in-memory queries executed in microseconds. We know in-memory processing is very fast. Saves up to 92% cost of infrastructure. Then you must be thinking, okay, Samarth, you have already also shown us H2 database, so it's also doing in-memory processing. But let me tell you one thing, H2 stores all the data into your RAM itself, into your running application JVM heap memory. So it's not a solution, because if you want to store petabyte scale data, you cannot just store petabyte scale data in your RAM. That would have huge cost. You cannot have that much of RAM, right? It would be very costly. So using MicroStream, you don't need to do that. You can have few GBs of RAM. You can store data on your hard disk and load whatever is required, do the processing and clear the data from your RAM. So that you can do the GC clear, garbage collection. This is the MicroStream repo. You can refer this MicroStream repo on GitHub. And MicroStream can run wherever your Java can run, because it's your Java library. So your Java can run on your desktop, on your premise system, your cloud setup, on Docker containers, or basically container systems, or native image, crawl VM native image, on various microservices which are JVM based. It can run on Android, it can run on JDK. Basically, it's like JDK 8, JDK 17, whichever JDK. So you can use MicroStream wherever it's a JVM based technology, whether it be Java, GraalVM, Kotlin, Scala, Scooby, Conjure, Android. And what's your data model? It's just a Java Pojo class, a simple Pojo class. Data model is Java class only, no dependencies. Here in JPA, we saw we had to use this JPA dependency and we had to add these annotations, right? So here there are no dependencies, no Pojo class. I mean, Pojo classes are there, just Pojo classes. No dependencies, no special annotations like @entity, @ID, @column, no special columns. No need for special super classes, interfaces, or annotations. Use existing classes as they are, no strings attached. Any Java types are supported. Use any types from third-party APIs. Design your object model freely without any limitation. Use inheritance is trouble-free. In JPA, if you'll try to create inheritable entity relationship, that's also something that's very complex to understand and complex to implement and to use. Okay, I mean, I've used it in past. Migrating to MicroStream is trouble-free. That's the best part about MicroStream. Any doubts so far?
That's a whole lot of benefits.
Exactly. That's where the power of MicroStream is yet not much realized, but it's very powerful because there's a knowledge gap. People don't know about much about it. So once people start, like people are already moving to it. It's been 3 years, but once more people will know it, more people will start using it because it solves a lot of problems. We can see how many problems it's solving for us. So wherever we need to store data and do JVM based querying and processing, we should go for MicroStream. Because if our entire logic is in Java, then it makes sense to use MicroStream because we can store data in memory. I mean, on the targeted data store, retrieve it very fast into the memory, do the processing and store it back to the targeted data store. In the demo, I'll show the targeted data store as my laptop file system, but the targeted data store can be anything. It can be your block storage, AWS S3 or GCS, GCP, GCS. It can be your any RDS, NoSQL database. Your targeted data store can be anything. They have support for majority of the things. You can read the official documentation. So now they have support for nearly all the things.
So Samar, that main computation goes to that conversion part. Like in JPA, it is an ORM, so it is converting that graph object to like we create an entity and it is stored in the database. But in this MicroStream, without like conversion, how we are dumping into that database?
That's what this framework is doing, right? It's directly dumping
Yeah.
the binaries into the targeted data store. Binaries, you cannot read it in the database, by the way. It's binaries. In order to read it, you have to load it back to the RAM. That's the catch here. You have to load it back to the RAM, and then you can query it using JavaStream's API.
Okay,
But
got
that
it.
that all MicroStream provides, right? I mean, loading and
Correct.
everything.
Everything ready to use. Directly use the code. It will do everything.
So they have removed the conversion part.
Yes, they've eliminated the conversion part completely. They're directly dumping the binaries and telling you if you want to query it, load it back to your RAM and query it using JavaStream's API or Java language. It's the best thing. Like
So
eliminating.
like it is free to use,
Yes,
like
it's
we have
free.
JP.
It's open source.
All right.
You can start using in your office work. You can build a POC, demonstrate to your company guys, explain them what this framework does, and then start using it. It's free to use. It's a library. Okay, how about persisting objects? So this is a JavaStream code. This is how simple it looks. You can initialize your root. You can use this simple to initialize the by default root location of your OS, and then use get customers and add a particular customer object to your targeted data store. So it will store the customer into your file system. It will dump the binary from your object from your RAM to your file system hard disk. This is the method. This is how simple the code is. So store any single object or subgraph explicitly. Binary data format, no expensive mapping, append only log strategy. Custom tailored type handling for best performance. Store any Java type, any suitable type is supported. Atomic operations and asset transaction safe. Multi-threaded write-offs for max performance. Replaces replaces 3 CRUD ops, create, update, delete. Use inheritance is trouble-free. Strong consistency, gigantic data throughput. The best thing about MicroStream, I can tell you, is it's the next level serializable framework because it overcomes the drawbacks of Java serializable interface. In Java serializable interface, how many of you have come across a situation where you're using a third-party library, Pojo object, and that is not implementing serializable interface, and you want to dump it to your file system? So it will not work, right? It will not get serialized. So you need to implement the serializable interface to your current object and to the subgraphs of your current object. So this basically MicroStream overcomes this limitation. It allows you to directly dump your object and all the subgraphs in it also directly into your targeted data store. This is the very big pro, you can say, of MicroStream over the Java limitation, serializable interface limitation. So you have strong consistency and gigantic data throughput here. So this is how it looks. Multi-threaded IO ops. You can concurrently store, write, and read. Loading objects dynamically into RAM. So what MicroStream we recommend is you use lazy fetching as much as possible. Don't use eager fetching. I told you before also, it's always best to have lazy fetching over eager fetching to efficiently utilize your RAM. So use lazy fetching as much as possible. Sufficient RAM is available. Restore the entire object graph if you have sufficient RAM, or just load the subgraph of your object graph and do the processing. RAM is limited, so use lazy fetching as much as possible. Load single objects or subgraphs on demand. No inconvenient object copies. Multi-threaded read ops. You can read parallelly for max performance. I think write is only single threaded, so you can write at one time in one object, but read multiple at a time. Loaded objects are merged into the object graphs automatically. So the binaries that is loaded from your targeted data store are automatically loaded back to your RAM, minimizing expensive IO ops. No more classic selects or simply call getter. So when you use MicroStream, you can simply call getter and get the object. No more classy selects or any fancy methods.
So this lazy is the my standard keyword, MicroStream keyword, right?
It's
LS.
a class,
Yeah,
static class.
yeah,
Like you can
yeah.
use this kind of a code. So you can get the latest one from the MicroStream. You can try out, read the document. It's very good. Reach out to them if you have any doubts, if you want any support, or reach out to me. I'll get you the help if you're going to use in your office.
So it means, I mean, based on that keyword, it is decided, right? I mean, the one that said we are using standard static class, whether it is lazy or eager.
No, here it's like you are doing lazy fetching here.
Hmm.
It's nothing
Mhm.
special. You're just doing lazy fetching. You're
So
saying that lazily fetch me orders. When I call this get orders, that time get me the orders. When I'm loading the customer objects, don't get me the orders. When I do this get method, that time get me the orders. Meanwhile, if there is any other things in customer, get me those details when I
and
fetch customer.
how about eager one? Eager fetch here?
By default, it is eager. So if
Eager
you
by
want lazy,
default. Okay.
yes, that's always in any technology. If
Mhm.
tomorrow you build a new technology, you'll keep everything by default eager so that people don't face issues and give up on your technology. I mean the programmers.
Yeah.
So how is the memory management done? Memory is fully managed by the JVM. Use lazy references if possible. Clear your lazy references which are not required anymore. In case of garbage collector issues, they recommend that you try Azure VM. Azul, sorry, my bad. Azul VM. Your object graph is your in-memory database. So this is what it is. Your object graph is your in-memory database. You dump your binaries, you load your binaries, and the conversion, there is no conversion because MicroStream allows you to dump your binaries and load back your binaries. Here in JPA and all the other things in the market, there is a conversion which is required. But that is required because when the data is stored here, you can also query the data here, but you cannot query the data here. In order to query it, you have to load it back. That's the catch. Is it clear? What's the catch and what's the pro and what you should do when you use this? Here are some of the links which you can use. Let me copy this, share over chat. Okay, I've shared the links with you. Refer these links and refer the other videos and everything, and you'll get to learn more. And follow me on LinkedIn. I keep coming up with these kind of trainings every year. So this is from last year.
You
I think
should
this is it.
do it every month, I would say.
You can recommend that to MicroStream guys, and yeah, I'll provide every month. Okay, any doubts about MicroStream, or is everyone clear about the theoretical part of it? Now I'll show you the pracs.
Clear, Samarth.
Okay. So this is a project which I've built. I've used Spring Boot latest version 3.0.2, and here you can see that I've migrated actually this project. So I'm using the latest version of MicroStream, which is compatible with the latest version of Spring Boot, which is 8.0.0.0, this version basically. I've added two of the dependencies: MicroStream storage embedded, MicroStream storage embedded configuration, web dependency to have the embedded Tomcat server, and for creating APIs, DevTools, Lombok, DevTools for rapid application development for avoiding boilerplate code, Lombok test, although I'm not using, I don't need. And I've created Swagger UI here. So I've added Spring Doc dependency, Open API dependency for creating the Swagger UI. This is my POM file. This is the location where it will dump the binaries in my laptop. So let me directly open this location. It will be in C users, user folder, and what is it? MicroStream Spring Boot CRUD. So here it is dumping the binaries. This is how the binaries look like. If you want multiple reads, then you can increase the number of channels. There is a configuration for that. I had done it in the past, but I don't remember now. You can check out my GitHub repos, MicroStream projects. One of the project I've done it. Okay, this is the base package. In the sub packages, we have the controller package, we have the entity package, and we have the repository. This is the simple looking Pojo class. As I told you, no fancy methods required, no fancy JP annotations required. Simple Pojo class with getter method, setter method, toString method, all args constructor, no args constructor. Student has student number, first name, last name. This is student repository interface. So we can add students, find all students, store all students, find by first name, find by last name, delete all. And this is the concrete implementing class. It's not really mandatory to annotate it with @repository, but I've done it so that we know that, okay, this is a repository class and I'm implementing my own interface, which I've created and providing concrete implementation below. Before that, I would like to show you this configuration. I've created list of student and I've created this variable here, embedded storage manager storage. And this is the boilerplate code that you need to write to configure the MicroStream. So this is the code. Here I'm providing the path location. This location is getting loaded from my property file. So this value will be set to this variable, to the string location. And this is the constructor. So when this class is instantiated, that time this will be configured. So I'm creating an array list of students. And this is the data structure for my MicroStream storage. And this is some boilerplate code that you just need to use as it is and provide your targeted data structure like this. So if you want to create some other like customer, then you create customer and add your targeted data store here. This is how you create different targeted data stores and store it into different locations onto your local file system, or to other targeted paths. It will be some different configuration. Then in the store all, we can see that I have created the storage here. I have configured the storage when this class is instantiated. Then in the store all method, what it will do is it will use this storage that I have configured here, storage dot store method, and it will store this array list. In order to store all the students, I'm passing this array list of students, logging it for debugging purpose in the past, and then adding it to this array list. So I'm adding this array list of students to this array list, and then I'm basically using the MicroStream storage store method to store these students. So I'm referring to this students, this array list over here by using this reference. And once I've stored it, I'm just returning back all data stored. Then similarly for add, it's the same thing, same store method. So I'm getting my list which I have above, and I'm adding additional student to that list and syncing my students, the object graph which is in the RAM with the object binaries which is in the file store. So I always just use the same method and sync whichever objects are in this, whichever objects are there in this list of students in my object graph or in my RAM to the binaries. This simply syncs objects from the object graphs in the RAM to the binaries in my file system. Then for find all, I'm simply returning this because it's already synced. And find by first name. So this is the query language of MicroStream. I'm using streams API, students.streams. So I'm referring to this students again, which is in sync with the binaries in the file store, targeted data store, which is my local file store. And here you can see stream, then filter it by first name, get me the student with a particular first name that I've passed over here. When I find it, I'm returning it. So whichever students have this first name, it will return that. Whichever students have this last name, it will return that. If I want to delete everything, I'll clear my array list and I'll sync my empty array list. So this is how I'm syncing my empty array list. So I'm using this minute. So I've created this store all method where I'm adding this empty array list. Basically, I'm adding this empty array list to the students. So I've cleared my array list, deleted all the students from the array list, and syncing an empty array list over here. And this gets the, where is the store all? This gets the empty array list. It adds the empty array list over here and syncs the empty array list. When you sync an empty array list with your file system targeted data store, it will delete all the binaries from there. That's how we manage the MicroStream storage. Now I've wrapped this student repository service class with this controller. So I've created these APIs. I've auto wired the interface. It will automatically create the concrete implementing class object at a runtime, because Spring Boot has IOC, inversion of control, dependency injection. So I don't need to auto wire this. I can auto wire the concrete. I can auto wire the interface. It will automatically create the object of the concrete implementing class at runtime. So I've auto wired the student repository. I'm using the methods that I've created in this IMPL class, store all methods, storing all students, basically just a wrapper over all the methods which I've shown you. Now let me show you the Swagger UI and how you access it. This is a main class, nothing fancy, simple looking Spring Boot main class. So this application has started and we can see the uptime was nearly 12 seconds. Now, what port it is running? It's running on 8080. Let's go to localhost 8080 Swagger UI Swagger UI index.html. So since I've added the open API dependency, this dependency which I had shown you here, this gives me this beautiful looking UI for testing my APIs. This is called as Swagger UI, and these are the APIs in my application. Let's first see if I have anything stored from previous runs or if I've deleted it. So currently my targeted data store is empty. I have not stored anything in the file system. Let's say I want to store some student with ID 1, first name Sam, last name Naru. I want to store one more student, so it's just JSON. Indentation doesn't matter for JSON. There is no primary key constant exception. I can have two students with ID 1 and different names also. So this validation you will have to manage. Okay. So these validations you will have to manage. There is no primary key violation constraint kind of validation in place, what you see with the traditional SQL databases, because this is not just meant for SQL database, it's meant for generic storage. So you can store anything. There is no restriction. So if you want to have a restriction where you cannot store a student, two students with same ID, you need to add that kind of logic in your code. You need to fetch that particular all the and check the in the targeted data store. If you already have a student with ID 1, then you don't store with this, you throw some exception. So that's not in place. I can show you. So there's no restriction. We can store these students. We have stored these students. We got HTTP code 200, all data stored. We can now fetch these students. So I can go to find all, execute, and I can see these students. Now, if I want to fetch someone by last name, I can fetch someone with last name. And I can see that I fetched some Sam with last name. Then if I want to fetch someone with first name, I can fetch someone with first name. If I want to, let's say, add only one student, let's say I want to add the student with ID 2, name as Ashish, and let's say Burr, and execute, and I can add another student added successfully. I can find all, execute, and I can see I've got Ashish Burr here. And let's say I want to get rid of all the students, delete all, delete, it will delete all the students. Now if I try to do find all again, it has deleted, so it's coming empty. So this is how you can wrap your storage with APIs and manage access to your storage using the APIs. So is this clear to everyone?
Yes, Samarth, clear.
Okay, good.
So it's all storing and syncing the location that you provided. It's happening there.
Yes, here. It's all storing and syncing here. The syncing happens on this line.
Storing.
Samarth, there is no concept of keys here, like primary key, foreign key.
Nothing. Nothing, no SQL concepts. If you want to enforce something, write it in your Java code and do it. Write the logic.
Mhm.
Where exactly we should write that? I mean, if at all we want to write.
Normal here, where you're storing,
Right.
check in your array list.
Okay.
Add your logic while adding to your array list.
Hmm.
So it is
Because
like more of the like file system type.
no, not file system. You can store into block storage on AWS S3 or
Okay.
GCS or
Okay.
database or NoSQL database, any object storage, graph storage, any kind of database, any kind of data store in the world.
Mhm.
I mean, whatever is supported by the library. Okay. So if everyone is clear with this, I'm stopping this application. We'll take 5 minutes break and then we'll move to the last one, which is many to many. So I know the time was still much further, but if we end sooner, we can end the session sooner. So welcome to this course, Spring Boot Hibernate many to many mapping. As part of your first hands-on, I'm going to provide you code walkthrough and functionality walkthrough of the application. So this is the application. This is the POM file. We are using the latest version of Spring Boot 3.0.2 and the associated Java version, which is 17. We have added the JPA dependency. One more thing. So Hibernate comes as a transitive dependency from JPA dependency. So JPA is a specification. Hibernate is its concrete implementation. So when you add JPA, it automatically adds Hibernate. So if I go into the effective POM, so right now I'm in the effective POM of this dependency, Spring Boot starter data JPA. So if I search here, Hibernate, so you can see that it already has the Hibernate core dependency inside of it. So I don't need to explicitly add the Hibernate dependency. So whenever I add the JPA dependency, it automatically has a transitive Hibernate dependency. So it automatically adds the Hibernate dependency internally because it's coming transitively. And then we have DevTools. So as JPA is a specification, Hibernate is a concrete implementation. There are other implementations also like Hibernate in the market, like Eclipse Link and other implementations, but hardly people use it. So majority of the companies in the world use Hibernate only. Okay. Then we have DevTools. Then we have H2. You know about this already. Lombok Web, and this which we don't really need. So I'll just remove it out. And we don't need this one also. Let me clean up the previous POM file also for you because I'll be pushing this code. So you can start using it. Many to many, many to one to many, one to many to one. So I'm just cleaning up the POM for you so that you don't have get confused looking at these dependencies. Okay, this is the main directory, resource directory, base package, entity package. Here again, we have auto-write the entity manager in the main class, and we are overriding the run method by implementing the command line runner, and we'll comment and uncomment these things as we go through different topics. Now make yourself familiar with the entity classes. We have a course entity class. It's a entity class. It has getter, setter, toString, hash code, everything. It has ID. Get familiar with the columns. So it will create a course table which will have ID column, name column, last updated date, created date. Then we have student class, student entity class, which will get mapped to a student table, and the student table will have ID column, name column. Then here the same thing, we have configured H2, added this so that data.sql gets executed on application start. And Then we have the other properties. Now, I've also added student reference material. So during the course, I'm going to show you some join queries. It is very big queries, so that if you're unable to write it or are getting confused while writing such a big query, you can copy paste from here. Now let me start this application and give you functionality walkthrough. So on application start, these two tables will be created and this data will be inserted. So in course table, we'll have these three courses: Spring Boot, JPA, Spring Boot, AWS Utilities, Spring Boot, PCF Cloud Deployment. Let's say PCF is very old now, so let's make it Spring Boot GCP GKE Cloud Deployment. Is changing the course name. Then we have these two students, Sam with ID 1, Hiran with ID 2. And our application has started. It's running on port 8080. We don't have Swagger here. Let's go back here. Let's go to the H2 console. Let's verify our login credentials. It's correct. Test ID, Sam. Have we set any password? We have not set any password. Let's connect to it and we can see the course table, the student table. Course has ID, created date, last updated date, name. Student has ID and name. This is the basic tables that we have. We can see that we have the data inside these tables. We have these three courses. We have these two students who are going to enroll in these three courses. So that's the code walkthrough and functionality walkthrough. Do you have any doubts about this?
No, sir.
Okay. Next, we'll move to this hands-on. Implement unidirectional relationship. Make course the owning side of relationship. So as part of this hands-on, we are going to understand, you already know the meaning of unidirectional relationship. So there's nothing to understand, right? You know the meaning right now, by now. What's the meaning of unidirectional relationship? So we are going to implement unidirectional relationship between course and between student. We're going to use many-to-many mapping annotation and we'll make course the owning side of the relationship. We'll view the join table that is created when course is the owning side of the relationship. In order to make course the owning side of the relationship, what do I need to do in the course? Can you tell me?
Uh, that annotation you have to use, right?
Yes, and add this over here. Since we are dealing with anything too many, there will be list of students here. So this is how we have made course the owning side of this unidirectional relationship. Now, whenever we use anything too many, it creates a join table. So let's see this join table. Now course is the owning side of the relationship. So we can see that it has created this course underscore students. It has these columns, course underscore ID and students underscore ID. So it has these columns. What we don't like here? Can you tell me what is looking like a bad database design, but it is not? This students underscore ID. We don't want any comma separated values and we will not have any comma separated values because here it will be one course and one student. Because one right, one to one, like kind of this in the table will not have one course
There
ID with
will be
multiple students.
multiple rows there. Or
Right. Yes, multiple rows will be there. So that means this column name is little wrong. By default, it is that way. So we can change that and I'll show you in the later topics, how we can change that. So as part of this hands-on, you have seen how we can establish unidirectional relationship between course and students, how we have used many-to-many mapping annotation. We have made course the owning side of the relationship. And when course is the owning side of the relationship, how does the join table looks like? Then, yeah, this is all we have done as part of this hands-on. If everyone is clear about this hands-on, we can proceed to the next hands-on. Is everyone clear?
Yes, Samarth.
Yes.
So
Yeah.
as part of this next hands-on, we're going to customize the join table name, this join table name. We don't like this name and the column names. So we'll just rename the column and the table and the columns. And we'll insert the data to the join table and write the join query to view the data, okay, between the tables. So view the default generated table name and column name when course is the owning side of the unidirectional relationship. So we have already seen this. This is the default generated table name and column names, and we don't like this column name because it has students. In real, it's just storing one to one, like student ID, course ID, student ID, course ID, student ID, and not course ID and students. Not just course ID and student side. It's not really storing comma separated values, so it's a wrong naming. So we are going to change that, and we're going to insert data into the join table. We'll write a join query to view the combined data of course and student table. We'll also fetch course and its student details by using entity manager. So very first thing, we don't like the naming, so we change the naming. How do we change the naming? So in order to change the naming, we need to add 1 minute. We need to add these things. I mistakenly removed it from here. Okay. Join column, join table. Undefined. Let me see what's the issue here. Let me compare it with here. Okay, it looks like annotation. It's not an attribute. I thought it's an attribute equal to the annotation, but it's just another annotation. So we add this join table annotation here, and whatever name we provide, it will be the new name of our join table. And using the join column, we are renaming the column name of the owning side of the relationship. So this is the owning side of the relationship, the column in the join table of the owning side of the relationship. And using inverse join column, we rename the non-owning side of the relationship. So non-owning side is students underscore ID, which we are renaming to student underscore ID. And this was as it is course ID. So we are just keeping it as it is. Okay, now that we have renamed it, what's the next step?
Did
Once
we
we have
rename it?
renamed, yes.
Did we rename it or we kept it same? I didn't get that.
No, we have renamed. I've just not refreshed this UI. I'll refresh it. Just seeing the next topic.
Hmm.
So we can then insert data into it, but just to make it clear and more understandable, I'll show the renamed object and then I'll insert data into these tables. So we can see that the table name has got renamed and the column names have also got renamed. We no longer have that students underscore ID, it's student underscore ID. Next is we're going to insert data into this join table. Which join table? This join table, course enrolled by students. Let's insert some data into it. When course is the owning side of the relationship, so table name is course enrolled by students, so we need to enter the data here. So here we are saying Spring Boot JPA has been enrolled by student with ID 1 Sam, and course with ID course with ID 1, which is again Spring Boot JPA, is also enrolled by student with ID 2, which is Hiran. Course with ID 2, which is Spring Boot AWS Utilities, has been enrolled by again both the students Sam and Hiran. And course with ID 3, which is Spring Boot GCP GKE Cloud Deployment, has been enrolled only by Sam. So we have inserted data into the join table. We can see that, I'll have to reconnect. We can see that we have inserted data into the join table. Now we'll write a join query to view the combined data of course and student data, course and student table, a whole join, full join. We're going to write a full join query, which is this query. This will get me all the matching data. Sorry, it's what is it called? Outer join, inner, full inner join. Okay, so we can see that what we have done is select star from this table from this table, from student table, from course table, where this table dot course ID is equal to course table dot course ID, and this table dot student ID is equal to student table dot student ID. So see here, where this joint table dot student ID is equal to student dot student ID, and the joint table dot course ID is matching with course and course ID. So from here we can say that Sam has enrolled for all the courses and Hiran has enrolled for these two courses. So Hiran has not enrolled for GKE course, GCP GKE course. Next is also fetch course and its student details by using entity manager. This you already know. We have auto-wired the entity manager and we're going to fetch. Now who's the owner? Course is the owner. So again, when course is the owner, we need to first fetch course and then students out of course. And what kind of a default fetch type we have? It's many to many. Anything that is too many is lazy. Since it's lazy and we have used @ transaction annotation, we're not getting uh, lazy initialization exception. If we don't add this, we'll get that lazy initialization exception. And if we add this, we don't get this lazy initialization exception because it keeps a transaction open throughout the method. So is this clear to everyone, all these points, what we have done, how we have done, or if you have any doubts, you can ask me, I'll re-show that particular point.
So this join query, we can also do it through this SQL.SQL file.
Yes, obviously. But it will be of no use to you, right?
Right.
So
Okay.
this will just execute internally and done. What's the use of adding? See, why I've added this here, you know? I've added because this file cannot be empty. And let's say I don't want to insert these things on application start. So I can just execute a simple query and not keep this file empty. I mean, there is some query should be there which gets executed on this file startup. Otherwise, the application start fails if you've enabled execution of this file. So for the safer side, I tricked the application by writing a select query. I mean, let me show you. Let's say I'm not adding anything. I'm keeping this file empty. That means everything is commented. So an application start, it will break. See, script must not be null or empty. This cannot be empty. So to trick the application, I've added the select query. This is how I tricked the Spring Boot application to have an empty file during the start. I think the restart is not happening. So I need to restart manually. DevTools is not able to handle this. Now you understand why I've added this select query here.
Yes.
And it's of no use to add, but it's again breaking. Why? I think because, yes, it's breaking because of this, not because of that. We are trying to fetch something we don't have. I mean, we don't have because we have removed it. Okay, so you can see that application has successfully started now. So just to trick the application, you can add a select query here, but it's of absolutely no use to add. I'll again add the insert statements. And who was the owner? Course was the owner so far. Adding course back here and these things, like we are retrieving these things. So is everyone clear so far till here?
Your examples were very easy to understand, actually.
Thanks. So the same, I mean, I built these examples around 3 to 4 years ago. I'm migrating the projects, keeping the concept simple and focus. I mean, keeping the use case simple and focus on the concepts. Because once you understand the concept and feature, then no matter how complex the business use case is, you can always execute, implement it. But if you don't understand the concept and the business case is business use case is complex, then it's very difficult to learn the concept with a complex business use case in hand. Okay, this is done. This one. Implement unidirectional relationship. Make student the owning side of relationship. So as part of this hands-on, what we're going to do is we're going to understand and implement unidirectional relationship. We're going to learn the use of many-to-many mapping annotation. Basically, right now, course first the owner. We're going to make student the owner and course as the non-owning side of the relationship. We'll view the new join table, how it looks when student is the owning side of the relationship. Basically, inversing the relationship. Right now, course was the owner. Now we want student to become the owner. So comment this out and add this. So now I'm making student the owner. That means I need to comment this out because this table will no longer exist. Also, I need to remove this. So now I've made student the owning side of the relationship, unidirectional relationship between student and course. And we'll have a join table with which start with something like student underscore courses kind of a. Let's see that in action. Let's log in. Here we can see student underscore courses with student ID and courses underscore ID. So this is the join table which gets created when student is the owning side of the relationship. Now let's customize the join table, the new join table. Let's use the same kind of annotations, join table annotation, and we'll rename that this one student underscore courses to student enrolled courses or enrolled student enrolled courses. I think, yeah, this sounds good. Student enrolled courses. Join columns, the owning side as student ID, will keep it as it is, student ID as student ID. And we don't like this courses. We want it to become course underscore ID. So we are renaming it to course underscore ID. Okay. Now let's insert data into this new join table. So now our join table is this one, student enrolled courses. So we are inserting data into this new join table, which is having a mapping of which student has enrolled into which courses. So we can see that Sam has enrolled into all the 3 courses and Hiran has enrolled into first 2 courses. So Hiran has enrolled into Spring Boot
So
JPA and
basically, same thing we are achieving with the using the other class, right? First we
correct.
achieve.
Correct. So we are just inversing for the practice purpose so that you understand the complete usage of these annotations. First, we made course the owner. Now we have made student the owner. Still, we have the unidirectional relationship here. We have switched the owner.
Yes.
Now we are going to write a join query like how we did before to view the data. Now, since we have a new join table, this will be the query.
The owner is now student.
Correct. Now student is the owner. Have we inserted data into the join table? Yes. Now let's execute this query. And from here, we can see that Sam has enrolled into all courses. Hiran has just enrolled into these 2 courses. Any doubts about this? How you can change the owning side of the relationship in the unidirectional relationship for many to many?
This was very clear.
Okay. What about others? If everyone is clear, you can write clear in the chat and then we'll move to the last hands-on.
Yes, clear, Samarth.
Okay, good. So this is the last hands-on for today. Implement bidirectional relationship. Make student the owning side of the bidirectional relationship between student and course. So as part of this hands-on, we are going to implement bidirectional relationship. And when we will implement bidirectional relationship, we'll see the problem of 2 join tables. And we'll implement the bad database design first because you should understand what is bad database design. So I'll actually implement the bad database design and show you how does bad database design looks like and what is the disadvantage of having bad database design. Then we'll fix the bad database design by making student the owning side of the relationship, or we can say by making student the owning side of the bidirectional relationship between student and course. Then we'll insert or remove all data with data.sql as needed for this exercise. We'll fetch student details from course and we'll fetch course details from student because it's bidirectional. So we can fetch anything out of anything. Okay. So very first thing we want to do is we want to have a bad database design. Let's create a bad database design. So I'm adding these annotations, the mapping annotations in both the entities over here also and over here also. So I will have two join tables, course enrolled by students and student enrolled courses. I can insert data into both the join tables. So this is one thing which I can do. I'll have to maintain data into both the join tables. Then I can go here, refresh, connect. You can see I have two join tables now and I'll have to maintain data in both the join tables. This is the pain point. So if you're having this kind of a thing in place, that means you'll have to maintain your mappings. You'll have to insert data for student and for course in both the tables. So it's a pain, but you can use any join query in this case, but it's a bad database design because you have to maintain data in two places. So let's have this query. Then let's have
Or many to many, right?
correct. This is the entire this course which you're learning now is many to many one. So you can see that when we use this many to many in both of them over here also and over here also, it's giving us, and we've obviously customized because we are inserting like this. That is why I've renamed it. I mean, we are inserting with these table names, right? So that's where I've also renamed the column names. And we can see that we can have the mapping in both tables and use this kind of both queries now. But it's a bad database design because you have to maintain the mapping in both the tables. How do you fix this bad database design? So what I've done right now is I've created a bad database design, and the disadvantage is that you have to maintain mapping in both the tables if you implement bad database design. Now, how do you fix a bad database design? You fix a bad database design by making one entity as owning side of the relationship. If we want to make student the owning side of the relationship, how will we make student the owning side of the relationship? Anyone? Quickly.
Like what we did earlier for, we use some
We have to go to course to make that no
yeah,
warnings.
mapped by. Yeah, that's some
Correct.
we did.
That's why.
So we are adding this mapped by annotation in the course to mark course as the non-owning side and student as the owning side. If course becomes the non-owning side, that means there will be no joint table. There will be no course enrolled by students joint table. So if there is no joint table and if we try to insert data, definitely the code will shout. So let's remove this. Now that we have fixed the application and we have made what we have made student the owning side of the bidirectional relationship between student and course as the non-owning side. So this is courses which we have copied from here and pasted directly here. Now we'll have one joint table, student enrolled courses, and we are maintaining the mapping only into that. Correct. So now this is a good database design. We have only one joint table. What's the advantage of bidirectional relationship? The advantage is we can fetch anything out of anything. We can fetch course out of student, or we can fetch student out of course. This is the advantage or the only advantage of bidirectional relationship in Hibernate. So this unidirectional and bidirectional is more of a Hibernate concept. Whenever you have bidirectional relationship, you can fetch anything out of anything. But the insertion order remains the same. But here insertion order is independent because you have a separate mapping table. So you can check in the logs that we are able to fetch anything out of anything. First, we fetch student details. Out of student, we fetch course details. And then we fetch the course details. And out of course, we fetch the student details. Is it clear to everyone?
Yes. So this we use with respect to H2 database, right? What
No,
happened
no. With anything, any
with
database.
anything, with
Any
anything?
SQL database,
Okay.
MySQL. This is for SQL databases. MySQL, Postgres, MariaDB, what is it?
Mhm.
MariaDB. Any SQL database.
Mhm.
So JP and Hibernate is specific to SQL databases. I mean, you can use it for NoSQL. I've used it for Mongo in past. The very funny thing was I still had to define a primary key. I mean, what's the use of tell me primary key in a NoSQL database? Correct. There is no use, right?
Yeah.
But still I had to add this because the framework is designed that way
Framework.
that you
Yeah.
need to.
Spring Boot framework is maybe.
Correct. So it's designed like this. You need a primary key when you use this JPA. So I have those I think Mongo over here. So you can just search Mongo. Alright, this is the node one. Spring Boot also I had done in past. Spring Boot. Okay, I don't remember, but it's there in one of the old repos. So that's all for today. If you have any doubts, you can ask me, or in the next 5 minutes, we can end the session.
Uh,
Samarth, in that many to many, if we want to add like in that mapping table, then how we will add, like there is no entity class for that
Many to many, you want to add?
in that mapping table, that enrolled student. Like you are adding records in that using that data.sql file. If we don't want to add like that,
In that case, you can use JPA, right? You can use JPA and add use the JPA method for adding things. So in the fundamental course, I've taught that. So you can, oh yeah, one thing is pending. I need to push this code so that you guys can refer it also, right?
yes.
Very important.
And I mean, either through the JavaPro or maybe on your own channel, can you also have some recordings or your own these simple examples for this JWT or authentication and security related thing authorization? Because some of those topics are really challenging to uh,
You can refer
code.
this one, JWT.
You have it, okay? Spring Boot security.
Yeah. So this I have built it with my student. He was experimenting with it. Okay, I need to first push the code so that this doesn't remiss. I think I have added Spring Boot Advanced, right? Spring Boot Advanced,
You
not
can create
Advanced.
today's date and
Yeah, no worries. Just create the name Spring Boot Advanced Hibernate. And MicroStream is also there, right? So Spring Boot Advanced Hibernate. Okay, 1 minute. Yeah, Spring Boot Advanced 1. I think this is sufficient. 1, and with today's, because yeah, it will get more trainings are coming, so with date makes more sense. 10th June 23. Spring Boot. I'll not add description for now. Okay, let's create. This is the path, right? Okay, I've opened it twice. This is the path. I'm adding from the right path so that you have the modified code and not the initial code. Oh, my bad. I'll just type it out. Let me, I think this got hanged. Let me open it. Okay, let's add the remote region. to confirm. Okay, I'm sharing the link in the chat. You can also stay in touch with me on LinkedIn. If you have any doubts, you need recordings, you've not received it. So you can reach out and I'll help you get the recordings. Okay, that's it for now. Like if you have any doubts, I can help you clear that. Yeah, so
Mhm.
you one of them had asked like how to add without that SQL file, right?
No,
So
Samarth,
for
my question was like I know how to add that using save and flush, but for that table is created. For that we
Mhm.
don't have Pojo class, right? We haven't created because in many to many extra table is created. How do we add to that
Um,
table?
good question. So we can use the custom queries there, execute the custom queries. Like custom queries also we can write in JPA, right? We
Okay,
can
okay.
have a custom query methods.
So
Mhm.
those derived queries and other things that
Correct,
you were
correct.
talking about.
I think I have this. I have covered the custom queries in the 2021 sessions, I believe, because that time we had a 2 days training for just fundamentals or something. So we had a lot of time to cover a lot of topics of one thing. So let me check that in which class I have. Custom query demo controller, got it.
Not sharing
I'm
again.
sharing it's JPQL. I'm
Okay.
sharing over chat the repo link.
You have
It's not
anything
part of.
also for microservices, small demo or that way?
Yeah, a microservices design pattern. Yes, I
Mm.
provide training over weekends. So
Mm.
if you guys want to join, you can create a group and come because individually it's little on the higher end. So you can create a group and come, and I can cover all those things for you, microservice design patterns and everything. You want to learn interprocess communication, right? How interprocess communication works. What are the
Yes.
different microservice design patterns, cloud modules.
Mm.
So what we can do is you guys reach out to me on LinkedIn. We can create a group and start your batch over weekends. Or if you want
And
to go one by one, we can go one to one also on weekends. I provide that. I have one student already. He's learning from last 1.5 years.
Samarth, one more small doubt. Like in all those examples, we have like single attribute primary key. Like if we have composite primary keys, then how do we handle in that cases? Like
Your
mapping.
voice, yeah, they're gone. There is a special, a different code for that for composite primary key. So all those things I can cover in the weekend sessions because it's not the part of this. But let me see if I have the code ready. I'll share it with you. You want to see how we cover composite primary keys. Here's the code. I'm sharing the code over chat. So this code shows how we handle composite primary key.
Thank you so much.
Okay, no worries. Okay then. Thank you everyone. Have a great day. And stay connected and stay in touch on LinkedIn. I keep coming up with these trainings. There are more trainings coming up. On coming Saturday, we have a training on Spring Boot security and AOP, aspect oriented programming. Do join that. Using AOP, you can build frameworks, and using Spring Security, you can add additional layer of authentication to your Spring Boot applications. And do stay in touch with technology. Keep learning, keep growing. Thank you. Bye.
Yeah.
Thank
Uh, for
just
the upcoming one, I think I have registered it, but I don't remember if you can send the link, maybe on LinkedIn or whatever.
Yeah, I've shared the link on the LinkedIn. No, let me just search again.
I have it.
Okay, let me share the link here. So you guys can also register for my coming Saturday training. Actually, I've
Yeah.
shared it long ago. I
Hmm.
think I'll have to go to my notes, iCloud notes.
Even if on LinkedIn you share, I'll pass it to my friends.
Yes, I need to advertise. I've not much advertised for that yet, so that students can see it and they enroll it. I'll share it across with you, all the links. Fundamental training is also coming, another batch. So those of you who have missed the fundamental training, please join the fundamental training also, because that will give you very good fundamental foundation in Spring Boot. Spring Boot training links, got it. So I'm sharing all the links here for 2023. And we have one more batch of this also coming up for Hibernate also, for Spring Security also, and for fundamentals. So do register for this. I shared over chat with you guys. And in all the trainings will be again covering MicroStream. So if anybody has not really understood what MicroStream does in today's session, you can register again for the next session and I'll be explaining there again. And meanwhile, you can try out the MicroStream POC. You can do a POC. Okay, anything else, guys?
No, this was really good. In a short time, I understood many concepts.
Okay, thanks, Sagar. And if you do like this training, please don't forget to comment on LinkedIn, and thanks MicroStream and JavaPro for funding this training for
Yeah,
you guys.
definitely.
Okay, thank you guys. Have a great week. Bye.